Yesterday I was solving a question and my network just destroyed the whole thing. Anyways, I'm just going to continue from that question. It was on. I was solving this question. I think I'd already solved it, but I was trying to optimize the solution. Right. It was this question intersection. It wasn't this one. Uh, it was this intersection of multiple arrays. That's one. Minimum common value. Minimum common value. Yes, this was the question. This was the question I was solving yesterday. So we had runtime error. I solved the question, but there was still room for improvement, right? And it needed to be adjusted, improved, all of that. But let's go. So today I'm just going to go through that and solve. And provide a few optimized versions. I think I did this one offline yesterday. Um, the stream was ended, so I had to continue solving the question. So here I used a set and got all unique number of one of the arrays, and then search through the array to see if there's a number that is in the second array, right? And if that number is also the minimum number, then we can return the number, otherwise we'll return -1. So let's read the question again, and I will provide a second method, which is the hold on, how do you call it, the two pointer method. I think yesterday I was trying to do binary search, right? At the end of the day I did the binary search, but obviously the solution wasn't you know it wasn't good in terms of runtime, right? The big goal of that solution was O of n squared, which is not really good, right? So quadratic time complexity. So I was doing that for the sake of, I was using binary search for the sake of you know um studying, right, and trying to remember certain things. Just it's just an experiment, I'll put it that way. It's not something I would want to do in terms of in an interview, but it's not something I would do in an interview, but I can just do that on my own in order for me to test out what works and doesn't, right? So I'll go back again, right? So let me go back to the playground. I want to show you, obviously this question is quite simple in the sense that we are just looking for the minimum intersection of two arrays, right? So here's the question. Given two integers, array nums1 and nums2, sorted in non-decreasing order, so our array is already sorted, right? Return the minimum common to both minimum integers common to both arrays, right? If there is no integer common amongst, sorry, let me read that again. Given two integer arrays nums1 and nums2, sorted in non-decreasing order, meaning our array is sorted from smaller integers to bigger ones, return the minimum integer common to both arrays. If there is no common integer amongst nums1 and nums2, return -1. Note that an integer is said to be common to both arrays, to nums1 and nums2, if both arrays have at least one occurrence of that integer, right? In other words, we'll look for the intersection between those two arrays, and also the minimum point at which that intersection occurred, right? So I used a few different methods yesterday, and they were not very optimized, but I was on implementing a binary search, right? So I was using a binary search to solve the question. Obviously, this will work, but it is not an optimized solution. I'm just doing this for the sake of learning and also, you know, an experiment, right? So let's see how we can use a binary search to set this. Although we don't need binary search here, but we can still use a binary search just to learn, right? So how do we implement a binary search? Now, why would a binary search work for this problem, right? So first of all, let's come back to this board. Here's our question, right? There's our input, right? Sorry, I need to bring this back. Okay, so we need to take this and that. Now, a binary search is a search for a specific value in an array. Now, for a binary search to work, you need to use 2 pointers, right? A pointer at the beginning and a pointer at the end of the. I don't know why this is so bold. Hold on. Okay, I see why. Right. So let's bring this here. Great. So in order for a binary set to work, we need two things, right? I mean, we need at least three stuff. First of all, we need a sorted array, a target, and 2 pointers, right? 2 pointers. So now when we take this array here, 1, 2, 3, right? This is already sorted. So for us to perform a binary search on this, it means we are looking for a particular value in an array, right? So 1, 2, and 3. Now we can iterate through every value in this second array nums 2 and find out if that value appears in nums 1, right? Now a normal or a conventional way to search for a value in an array is to iterate through the array and compare every value in that array to our target. Say for example, we are looking for this value here, which is 2, right? 2 like this. So for us to search for 2 in this array, I'll say this is num1, I'll call it n1. For us to search for 2 in n1, a conventional way is to iterate through n1 and compare each value in n1 to our target, right? So we can say n1 at index 0 will be equal to 1, and 1 is not equal to our target. This our target is equal to, I'll put t equal to 2, right? So n1 is not n at index 0 is not equal to our target here. Our target is 2, while n at 0 is equal to 1. So we go through again a second iteration. So we'll say n2 is equal to n1 at index 1, right? Which means second iteration will be equal to 2. N at index 1 is equal to our target, right? This is the same as our target, so it means we found our target, so we stop the iteration at this point. Now you can see if this target we are looking for was part of a larger array and it's not at the beginning and it's not somewhere we can find easily. Let's say our n1 array had values up to 50, right? And our target is probably 20. It means we'll have to iterate 20 times before we get to our target, right? It means we have to iterate 20 times before we get to our target. But with a binary search, things are different. It is a much more optimized way to search for a value in a given array. So how do we perform a binary search? Like I said, we will need 3 things to perform a binary search. We will need a sorted array, a target value, and a pointer, right? Or a set of pointer. So Here's how a binary search is done. Let me copy this. I'll say this is n1 still. Let's still use this n1 array. Now we want to search for 2 inside of n1 using a binary search. Well, with a binary search, we need a sorted array. So we have our sorted array, which is n1 already. We have our target. So the next thing we need is the 2 pointers. Now, where do we put both pointers in our binary search equation? So we'll need a pointer at the beginning of the first array, the sorted array, sorry, n1, and another pointer r, so left and right, at the end of the array. Now, here's how we perform a pointer. So here's how we perform a binary search. So after putting these pointers at their respective positions, we need to find the mid value or the midpoint of this array, right? So the midpoint will be the left pointer plus the right pointer divided by 2. Now we need to round up this value, right? So we can get the nearest 0 value. So, or the value nearest to 0. So this is left plus right. In this case, left is at index 0 and right is at index 2. So if we do left plus right, left is at index 0, left is at index 0, right is at index 2. This is 1, 0, 1, 2. So we'll do 0 plus 2 divided by 2, right? This is 2 divided by 2 is equal to 1. So our midpoint is at this position. Here is what we compare to our target. Now, if this is equal to our target, we stop the iteration. It means we've already found our target, right? So we'll do this to say, I'll say m, since m is equal to 2, right? So n1 at index m is also equal to n1 at index 1, because m here is equal to 1, right? So this is also equal to our target, which is 2, right? So it means we found our target already. Let me remove this, sorry. It means we found our targets already, right? Now, unlike the conventional way of searching for a value in an array by iterating, right, and comparing each value in the array, a binary search shortens the steps, right? We are still iterating through the array anyways, but this time around it takes half the steps to find a particular value in the array using binary search. So let's try a binary search and see how it works. So I'll create an array here. I'll create let me copy this. So this is, I've already started it here, but I think I should still go through everything again. So I'll erase all of this. I'll leave this part here. So for a binary search, so we defined a function called binary search. This is a helper function that will return a value once we found it, right? So a binary search will take a target, right? I'll call this target just for the sake of understanding this. So I'll say this is target. Now the target is a value that will search in the second array. So I'll say our first array should be the array we are performing the binary search on. So we would need 2 pointers, right? We'll need a left, and the left pointer will be at index 0, and right is going to be at the last item in the array. So this is going to be the length of the array. So we are using DOMS2, right? We are using DOMS1 minus 1. So we've pointed the right pointer at that position at the end of the array. So what we need to do is to perform the binary search. So the binary search goes like this. Write a while loop and say while the left pointer is less or equal to the right pointer, right? We need to shift them accordingly based on certain conditions, which we'll see in a bit. So first of all, we need to find the midpoint. The midpoint is going to be equal to the left pointer, so left plus right, sorry, left plus right divided by 2, right? Now I'm using double division sign because this is going to give me the nearest zero value, right? So we need to get it that way. So we'll get the mid value as well. I'll call this mid value and set the mid value to be the value in nums 1 at this midpoint here, right? And then we begin to compare. We say if the mid value, right, is superior to the target, right, here's what we need to do. If the mid value is superior to the target, we need to shift the right pointer towards the left pointer, right, or one past the midpoint. So this is going to be right equals to mid minus 1, right? Else if the mid value is less than the target, right, if the mid value is less than the target, then we need to shift the left pointer towards the right pointer. So it's going to be mid plus 1. Otherwise it means the third condition that will happen is that we found the value at that midpoint, right? So if we found it, then we return true. Now we want to return true because we are using this function here as a helper function so that we can return a specific value, right? So return true. Return true. Otherwise, when we are done iterating and we didn't find the value, we'll just return false. So that's it. So let's say so we iterate through the second array for nums. Okay, I'll say for num in nums 2, right? For num in nums 2, if the binary search of this num return true, right? If the binary search of num return true, then we return the number. So return the number. Otherwise we just return false. I mean, we return -1 if we don't find that number. So return -1. And let's test this out to see if it's going to work. So I'll quickly copy this and paste it in LEETCODE for that. Now this is not a very good a fast solution in terms of runtime, because this is going to take O of n runtime and fixed amount of space. I think yes, we are not creating any more space in memory, so that's good. So can paste this here. Let's run this and see. Now you can see this solution works, right? It works just fine. But again, this is going to be a very slow solution. If I submit this, you'll see it works, but you can see the runtime is really slow, right? It means this solution is slow. So how else can we optimize this? Well, another way we can optimize this is by using 2 pointers. Now, one mistake I made yesterday was I was always thinking, I need to use 2 pointer on one array, right? I didn't even think about using both 2 pointers on 2 separate arrays simultaneously, right? So here's how we can do that. So for us to use 2 pointers on 2 arrays simultaneously, we simply need to point at these values here. So we'll say we can do this. We can say for the first array, right? The first array is like this: 1, 2, 3, right? It's already sorted. And our second array is also 2 and then 4. Now we need 2 pointers. Now these pointers will not behave like the conventional 2 pointers on a specific array. So both pointers will start at the same position in their respective arrays, right? So for this first array here, I'll have a pointer called I, which will start at index 0, right? And another pointer J, which will start at index 0 here. And then we'll compare these values, right, while we iterate, or while we shift the pointers throughout the arrays, right, throughout their respective arrays. So for the first, in the first iteration, right, in the first iteration, we can say pointer at this position, and this one will point this at this position as well. So we'll say value at norms, I'll call this n1 at I, right? If n1 at I is equal to n2 at I, at j, sorry, n2, this is n2 and this is n1. So if these values here are equal, then it means we found our minimum common value between these two arrays, right? Otherwise, we keep shifting the pointers, right? So we'll shift this I to the next value, and also shift j to the next value again, and compare, right? If they are not equal, right, we'll shift again. But in this case, we can't continue shifting because this left pointer here has, this this j here has reached the end of this array, right? So meaning we can't continue the iteration. So it also means that there is not going to be a common value between two of them, right? So we then return -1 in that case. So how do we do that? So let's come here, right? I will need to so let me remove this. Let me commit this first, and so I'll say, you know what, let me leave this. I'll call this solution 1. I'll just edit the name of the file. I'll say refactor rename. This is going to be equal to solution 1, like this. Or let's say, yeah, okay, let me call this example or solution -1, right? I think I should put it in caps so that it doesn't look like the name of the question itself. Solution 1, yeah, this is better. And for the second one, I will create the same file again, so I can perform the other one here. I'll call this solution 2. Okay, we need solution 2, right, like this. Okay, that's all right. So let's copy this. We just copy the starting of the question, the boilerplate code, so let's close this. And so here's what we need to do. We'll first of all use 2 pointers, right? So let's create our pointers. We need a pointer I and j. Since both are going to start with 0, I'll just say pointer I is equal to pointer j is equal to 0. So the next thing we need to do is to start the iteration, right? So we'll say while the left pointer, right, while pointer at I, and this is going to be I, while I is less than, or while I is less or equal to the length, we can do less than the length of nums1, or less or equal to the length of nums1 minus 1, right? So this is going to be less or equal to, I'll prefer to do it this way. While I is less than the length of nums1, right, and j is also less than the length of nums2, right? Nums2. Then we begin to compare the values, right? So we'll say if nums1 at I is equal to nums2 at I, right? At j, sorry. Nums2 at j. Then we just return the number. So we return we can return either nums2 at I or nums1 at I or nums2 at j. It doesn't matter. They'll still have the same values, right? So return nums1 at I. And then in the case where we don't find an equality, we need to shift the pointers, right? So we'll say j plus equal 1, I plus equal 1 as well, right? So let me space this out a bit. So like this, j plus equals 1 and I plus equals 1. Now, if we reach the end of the iteration and we don't find any values, sorry, let me split this out a bit. Then we can just return -1. So return -1 like this. Okay, so let's test this out and see if this will work. So I'll bring this back. What's this here? Okay, 5 points. That's the first submission using a binary search. Alright, so we can run this now. Okay, something happened here. So what's going on? Oh, both solution failed. Why is that? Let's see. Why did this fail? Nums1 and nums2 output is -1. So hold on. Plus equal 1. J plus equal nums2 nums1. What's going on? If nums1 at I is equal to nums2 at I, well, wait, I must have made a mistake somewhere. So let's take a look back. I'll copy this, right? Nums1 and nums2. Let's troubleshoot here. So I'll say solution okay, len of nums1 and len of nums2. Solution is going to be equal to solution here dot, sorry, Christ. So let me instantiate this first and print solution here dot get common, and I'll paste these two numbers here, nums1 and nums2. So I'll put nums1 here, then nums2 here like this. Okay, so let's see what happens. We have -1, which is wrong, right? So that means there's something happening. In fact, if you okay, so I see what's going on here. Now the reason why this is not working is because okay, I see why. So let's say instead of comparing these two values, we are comparing the arrays directly. I'm comparing the arrays directly, which is wrong, right? So how about comparing? So if num here, if num in this, right? I mean, we don't even need to. Okay, I still want to use 2 pointers, right? I mean, otherwise I would have used the set on one array and check if that value is in the other array. But that's not what I want to do here. I want both values to okay. So Now, the explanation I gave here is 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 wrong because um the arrays don't have the same size, right? So moving the pointers simultaneously will not work. So we need to move the pointers based on a certain on certain conditions, right? So how do we do that? Um, so we need to move them simultaneously. So both pointers. Um, I mean, I don't want to use a nested loop. That would be wrong. Oh, I thought. So we start both pointers at the same point, right? So we can't compare both values like this. Do we move one pointer before moving the next? I mean, if we moved this pointer away while we are also moving, then we will never get the value, right? We're never going to get the value that way. So, uh, there needs to be a way to move the pointers. Doing it this way won't work, obviously. Um, we could use a set, but I mean, we don't need two pointers to use a set, right? So let's see if somebody used two pointers here. I don't want to look at somebody else's solution, but I think there's no need to be stuck some here trying to figure it out. Just, you know. Okay, so all right. So if oh, I see. So return no matter if they are equal. Otherwise, we can return. So based on the set condition, if num at j is superior to num, okay, I see. Oh, that's my mistake here. So we don't increment it immediately, right? We need to increment j and I based on certain conditions. Now, if j has the larger value, right, or if num at I has the larger value, then we need to shift it, right? So we'll say if the num at I is superior, or if num at I is less than num num at j, right, like this, then we say j, sorry, we need to shift I, right? So say I plus equal 1, else we'll say um j plus equal 1, like this, right? Hold on, if num at I, sorry, nums 1 and nums 2, yeah. Now you see this works just fine, right? Let's see if there's any edge case here. There's at least one item in the array, which is good, and the values in the array range between 1 and 10 to the power of 9. That's a lot of numbers, but yeah. So we see. Let's see. Okay, so this is a better solution. The time complexity of this is quite um okay to, I mean, way better than the other ones, right? So yeah, we can just, I'll push this to GitHub now. So here was my mistake. If nums1 at I is less than nums2 at j, then we shift we shift the right I, so we increase I, so I plus equal 1, else we do j plus equal 1, right? So let me close this. That's it for this solution. This question is done. I can push this to, I can commit this now. So I'll say, did I commit the other one? No, I did not. So git add git commit dash m. We can say this is 2 pointers, right? 2 dash pointers, and the question is leet dash 2 540 git. Yeah, so it's committed. All right, so let's move on to another question. The next question on the list would be to solve intersection of multiple arrays. Difference of two arrays. I'd already solved this, so we're not solving this one anymore. Although this is also, these questions, I chose them specifically because they are quite similar to one another, right? I mean, the techniques are basically the same. So yeah, I'll close this, I'll close that, and let's solve intersection of multiple arrays. Now, intersection of multiple arrays, given a 2D integer array nums, where nums at I is non-empty of distinct positive integer, right? Return the list of integers that are present in each array and sorted in ascending order. Return the list of integers that are present in each array, right? Return a list of each integer, right? I mean, a list of integers that are present in each array, right? Sorted in ascending order. Okay, so well, first of all, is our array sorted here? Are these arrays sorted? Okay, they are not, so that's good. Now, how do we, let me copy this, right? I'll bring this here, paste. Oh, okay. You know what, I prefer writing out the arrays myself. So let's see. we have an array like this. This is going to be our first array. Our first array is 3, 1, 2, 4, 5. First array. Second array is 1, 2, 3, 4. Sorry, 3, 4, and 3, 4, 5, 6. Okay, let's remove this here. All right. So we can first of all, there are a few things we can notice from this input, right? 3, 4, 5, 6. I'll write it back. 3, 4, 5, 6. So we have 3, 4, 5, 6. Okay. So, hey, hello, ransom. Okay. So we have a few things we need to notice from this. First of all, number one is each array is not sorted, right? One, the arrays are not sorted, so not sorted. Number two, right? Number two, the question is asking us to find, right? To find each item or an integer, a list of integers that are present in each array, right? So a list of integers that are present in each array. In other words, the intersection, right? The intersection between these three arrays here. So every value we find here, we also have to look into this place, right, to find that value as well, and also into the other array. So now here's what we need to do. How do we find because look, it says find, where's this one? Given a 2D array, integer array, where a 2D integer array norms, where norms at I is non-empty, is a non-empty array of distinct positive integer. That's just too much. It's just a mouthful. Anyways, return the list of integers that are present in each array, right, of norms sorted in ascending order. Now, what's their intersection? That's what the question is asking us, right? So we need to find the intersection of every value between all the arrays. So number two is going to be intersection, right? So we can take the first array, right, and find out if a particular value, right? So say first array 3 here. So we check if 3 is in this array, right? If 3 is in this array, then we'll find out if 3 is also in this array. So if 3 is also in this array, so I'll call this result. This is going to be result, right? The result is going to be an empty array. So I'll call this res is equal to an array like this. So we start from the first item in this the first value here, right? We can take this first value and find out if that value is in this array and also in this array, right? So how do we do this? So we take value at index I, right, and check this array here. So we find through this array, so we found it here, so it's at this index here. So we don't add it here to the result because it has to also be in this third array before we can confirm its presence, right? Or we can confirm it as an intersection of the three arrays. So here is 3, we have 3 here as well, and we also have 3 here, so we add 3 to this result. So in the next iteration, or in the next search, we can search for 1. Is there 1 here? 1 is here, but 1 is not in this array, so we don't add 1. We have 2 here. Do we have 2 here? Yes, we have 2 here, but we don't have 2 here, so we don't add 2 in our I'll just mark this out. We don't add 2. We have 4 here. We also have 4 here. And we have 4 here as well. So we add 4 to this. I think there's no 5, so we don't need to search for any other value. Now we can see we have 3, 4, 5. Now the problem with this here is, although this will work, but this will work, right? But we need to know how many arrays are in the norms. So this is going to be is an array of arrays, right? So our input is like this, but our input contains arrays, and we don't know how many amount of arrays our input will contain at the end of the day, right? So here's what we need to do. We can use a counter, right? We can use a dictionary and create a dictionary of the first array, right? Of the first array, and then iterate through the rest while creating a dictionary for each one of them, and then compare the occurrence, right? The occurrence of every value in this dictionary here, and remove that value if it's not present in any of these arrays, right? So this question is actually similar to this question here, where I'm coming. Let me bring that out. So I need to repeat sets already for that's nice. So this question is actually similar to this question here. I need to bring that question up, where we found the occurrence of letters in an array, in a string. Sorry. What's that question again? I think it should be here. Similar question. Oh, sorry. Similar question should be here. Similar questions. Letters. Find the difference in two words. What? They didn't put it here. That's brutal. That question is very similar to this one. Oh my god. I solved that question yesterday. It was LEETCODE number what? I think I have it here. I should have it somewhere here. Hold on. I need to pull it up. Anyways, you know what? Let's solve this question first, and then I will show you how the question it is similar to. I don't remember the number specifically, but so we need to create a dictionary. So I like to solve the questions in my code editor first before I solve it here. I post it here because I don't have all the, you know, the suggestion in LEETCODE, or the, how do you call it? Is it lint, or anyways, I've forgotten the name. So let's see. What's the number? 2248. So this is lit. Wait, where am I creating? Okay, so it's in array. So lit dash 2248, right? Lit 2248 dash lit 2248 intersection of multiple arrays. Intersection of multiple arrays. Okay. All right. So let's copy this again. That's the boilerplate, and I'll paste it here. So I need to import the list class. I mean the list module here to avoid that error. Now let me go through the solution one more time. So here is how I'm going to solve this. I'll erase everything here. Oh, not that. So I'll create, first of all, I'll create a dictionary of the first array, right? In other words, I want to just create the dictionary and count the frequency of every value, right? So we can say the first array at the end of the day will look like this. I'll call this n, or I'll say a1, right, which is a1 or l1. A for array, L for list in Python. So so we'll have 3. 3 is going to be 1. 1 is 1. 2 is 1. 4 is 1. 5 is 1. Right? You know what? Let me create this properly. I can do it this way. I can say 3, 1, 1, 1, 2, 1, 4, 1, and 5, 1. Right? Let's just do it this way. I have the second list. I'll set this to 1, 1, 2, 1, 3, 1, and 4, 1. Right? Now, this will be created at first, but A2, right, will act as a will be created dynamically in every iteration. So for the first, in our first we'll first of all create a map of every value in A1, in A1 like this, and then iterate for the remaining values in the array and create the dictionary for those values each time. Right, now we will then check, right, if a particular value in this array is whether that value is not in this array here. If it's not, then we just simply eliminate it from the array, right? So we can eliminate it by simply setting its value to 0. So we'll say I'll use another column. So we'll compare it. So we'll say it's 3, right, in this. So it's so A1 has 3, right? So we'll find out if 3 is also in A2, right? So A2 has 3 as well. So we leave 3 as is. A1 has 1. There's also 1 here, which is good. 2 here as well. 4, there's 4 here, but there is no 5 here, right? There is no 5 here. So since there's no 5 here, we eliminate 5 by simply setting 5's value to 0. Okay, so 5 is back to 0. Now we'll do the same thing for the second list, right? So I will erase this. I will erase every value here. So we'll say here we'll have okay, let's continue with the whites. So the second one has 3 set to 1, 4 set to 1, 5 1, and 6 1, right? Now we can compare each value here again. We can say so 3, there is 3 here, right? 1, there is no 1 in this array, so we set 1 to 0. Is there 4? 2, is there 2 here? There's no 2, so we set this to 0. 4, there is 4 here, so we leave 4 there. And yeah, so there's 5 here, but there was no 5 in this one, so we already deleted 5, so there's no need to add 5 and 6, right? So there's not, so our A1 array will become like this at the end of the day. So we'll have A1 will become 3 1 time, right? 1 is going to be 0, so meaning we've removed 1. We also removed 2. We have 4 only once. At 5, we also removed 5, right? Now you can see our array becomes our A1 dictionary becomes like this. So we have 3 1 A1 4 appears only once as well. So we can then return this in a form of an array, right? So by simply using the list method, right, Then we can say a list of this list of so list of A1 will become an array of 3 and 4, right? And we can even put the sort function just to make sure that the array is actually sorted, because we want a sorted array of every you know, every integer that is present in all of the arrays, right? So let's go ahead and implement this. Now if we don't find anything, we can return an empty array, right, which is this one here. So the the constraints here are such that there's at least one array in the the input. There's at least one array, and the sum of every value, so it means there's also at least one value in the nums array, right? And yeah, so there's more than, so nums at I and nums at j, which means nums at I and j means the value in the nums array. So this first value is going to be between 1 and 1,000, right? So and the length of the array itself inside nums can be between 1 and 1,000 as well. That's a lot. Okay, so let's see. Now our solution, before we come back to our solution and analyze the time complexity, let's implement that first of all. I'll say this is going to be first of all, we need to count every value in an array. I've showed you how to count values in an array, right? Oh god, sorry. Okay, so we can use the counter module to do that. So say from collections import counter like this. Okay, so with this counter we can count every value in the array. So we can say okay, so first array will be so I'm going to say okay, so let me call this I'll call this a tracker, just the way I did it. I called it in the other question. I'll say this tracker is going to be equal to a counter of nums at index 1, right? Sorry, at index 0, which is the first array in the nums array. So then we can then iterate through every other value to the remaining values in remaining arrays in nums, in this nums array. Oh, that's a mouthful. I'll keep saying arrays and arrays. Anyways, so we can do this. We can say for every nums, for nums in, okay, we need to use I so that we can get the next value, right? So for I in range, we can still use nums though, right? No, range will return the index instead. So okay, so for range we want to start from 1, right, all the way to the length of nums. Okay, want to say now we begin to, we'll create a, I'll call this current count. So this is going to be another counter. So counter of nums at I, right? Counter of nums at, so this will create a dictionary as well, right? So we can then use the current count. So the current count will become our A2, and our A1 was already created. at the beginning, right? So A1 is the tracker and A2 is our current count. So we can use we can use the current count. Now we'll search for a specific, for every value in tracker, right? We can check if that value also exists in the current count, right? We'll say for num in tracker, right? In tracker, right? If num not in current count, then we can set num, right? Sorry, tracker of that num to 0, of num to be equal to 0, right? And that's all we need to do. So we need after creating, so we'll say here, so we'll say for every value in the tracker, so we are done with tracking and eliminating any number that is not common to all the arrays in the nums array. So we can say this is going to be, so our tracker will be a dictionary. So let me show you what our tracker will look at the end of the day. So let me print tracker. Yes, I'm just going to call this, so solution is equal to solution, an instance of the solution class, and we'll say print I can just call this, right? It doesn't matter. So solution dot intersection, let's copy this array here, is going to be our input, so you can see what goes on here. So let's run this. You can see our tracker now has, so you can see we removed 1, we removed 2, and we removed 5. So all we have now is 3 and then 1, right? So we can use 3 and 1 now to create our sorted array. So here's what all we need to do. Can we create a list from a dictionary straight away? So let's say print list of tracker, right? Tracker like this. Would this work? Nope. It will still put in the other one. So we need to make sure that we are removing every value here. So we can say okay, so we'll just iterate. So for output num, we need to get the value and the count, right? I'll say num, for num count, right, in tracker dot items, right? We need to get that. So this will return a key value pair, right? So we'll say if so we'll create our result array here. So I'll call this result is going to be equal to an empty array, right? So if the count is superior to 0, meaning if it has not been eliminated, right? If the count is superior to 0, then we want to add that number to the result array. So result dot append num, right? And yeah, so at the end of the day we want a sorted number, right? But let's first of all see what results looks like. So instead of, okay, I'll put tracker there and print the result as well. Print results like this. So let's see. Now you can see we have 3 and 4, so which is already good. So we can then return the sorted form of results, right? I'll just remove the print here. I'll say return results dot sorted sort. Okay. So what's going on here? What's this? Oh, okay. So you know what? If the results could be empty, right? Now you can see the results could be empty. So we can say return results, right? If not results, right? Uh else return this result or sort. Okay, so if we don't add anything in the result array, then um we just return the empty array. Otherwise, we can return a sorted form of the result. So let's take this and run it in LeetCode. Okay, so here's it. Let's try this out. Okay, so there's a wrong answer. What happened here? I'm returning an empty array instead of 3 and 4. What? I just tested this and it worked here. So what's going on? Let's see. Let me print the result here. This is impossible. So let's run this. Oh, none. That's true. So what happened? Return result if the result is, we added every value in result, right? Print result and see. Print results. Okay. Yes. Oh, sorry. If okay, return results. Hold on. Return results dot sort. Else just return the results. How about that? None. Okay, wait. Result dot sort. You know what? Let's sort it first. Result dot sort does not return anything. I'm sorry. Result dot sort, right, is not a value. It just sorts the array in place, so we can return the result. Else, just return the result, right? Just return the result. How about that? Yep. So we can just do this. This is better. This is better. This works. Okay, so that's good. So we can just simply return the result. We need to sort first before we return. That was my mistake. So results dot sort. I'll just copy this here. I don't have the autocomplete here, so yeah. So this is it. Okay, that's good now. So let's run this again. Test cases passed. So let's submit this. Hopefully this works. Yeah, it worked. We have 40. So the time complexity for this solution, so at this point it is going to be O of n squared, because we are running a loop inside another loop, right? We are creating a result which takes another space, so that's already O of n, right? Otherwise, if we're not creating any additional space, it would have been O of 1. So this is O of n squared, another O of n here. So at the end of the day, our the time complexity for this solution is O of n squared, right? So my time for this session is up. So I need to wrap up today. Let me check if there are any questions. Okay, so we have a few questions here. Hi, how to get all your 67 videos on DSA? They are in the live tab, so you can check the live tab to see what's there. Yeah. So Ransom said after achieving 100 day, um, I need to repeat sets. Oh, thank you for the compliment about the glasses. All right. And Comfort was here. Says you inspire me. Um, I would love to speak to Comfort one day. That was a very good compliment. Thank you. Okay, so I think that's the end of this session. Let me quickly push this to GitHub. So I need to commit this one as well. So say git add git add git add git commit. Oh, okay. Say after achieving 100 days, what are you going to do? Uh, I don't know. It depends. I probably apply for more jobs. I mean, applying for jobs is the main goal, right? But I might still continue creating more videos on data structures and algorithm, right? After the 100. So after the 100, apply for jobs, create more videos. Yeah. So let's see git commit dash m. I'll put this as 200 days. No. 200 days. That's almost a year. Streaming every day for a year. That's difficult. It's extremely difficult. So git, I'll say git leads. Oh, sorry, this is arrays. Hold on. Arrays, yeah. Oh, thank you. Arrays lead dash 2248. Yes. I'll say git push origin main. Okay. So please, you can get all the solutions on GitHub. This particular link is in the link in the description below. So you can use this as well. All right. I think since there are no more questions, I would continue tomorrow. Thank you guys, and thank you Ransom for wishing me luck on getting a job. And I'll see you guys tomorrow. Oh, how old are you? Let's say I'm in my 20s. Yes, early 20s. That's about right. All right. Bye.